Okay, so Coulomb's friction is normal metal to metal or solid friction. Viscous is the fluid friction. So when the input increases, so this is the threshold. What is the threshold? Threshold is the minimum input above which an output can be sensed. So below to the threshold there is no output. So this is the minimum input above which an output can be, you can sense an output, that is a threshold. Okay, so the input increases, if you see, input increases, but when you reduce the input, it does not come back in the same line, but it takes an alternative path. Okay, so this alternative path here and is called hysteresis. This is due to the hysteresis. It won't take the idealized straight line path, okay, but it takes some deviated path. So this deviated path, if you see, this is that hysteresis, this is that um, uh, level of hysteresis happening due to the Coulomb's friction. If you see, if it in this if in a fluid the fluid system or an hydraulic system, the input increases, it increases in straight line, but output, what happens when the input increases, it takes when the input increases, it takes an idealized path, but when it reduces, it deviates from the idealized path due to the friction, due to hysteresis damping. So this phenomenon is common in instruments. This is one of the static characteristics. Next, another important characteristics is the dynamic characteristics. So what is this dynamic characteristics? So let's see. The instruments rarely respond to the instantaneous changes. Instantaneous changes, what is instantaneous? Quick changes in the measured variables. So their response, however, their response is slow or sluggish due to, as we already seen, that when the system has energy storage elements such as mass, thermal capacitance, electric capacitance, inductance, etc., mass storage element, there is a delay. So sometimes even the instrument has to wait for some time. Instrument has to wait for some time for the output response, because the energy is getting stored, or because there is a delay caused by these energy storing elements. Okay, so these type of instruments are normally used, so we use only we use this type of measurement of quantities that fluctuate with time. Okay, so what measurement of quantities that fluctuate in time, in the sense there are quantities that change rapidly as time increases. So how can you measure? So what happens when you measure these quantities? So those specifications of how your system responds to the fluctuating time fluctuating quality is given by dynamic characteristics of the instrument. So the behavior of such systems, whereas the input varies from instant to instant, the output also varies from instant to instant, is called dynamic response. Hence the dynamic behavior of the system is also as important as the static behavior. Okay, so transient and steady state periodic response. So dynamic response has two regions. One is transient. It is defined as the part of the response which goes to zero when the time becomes large, and while the steady state response is a response that comes in a definite periodic cycle. So steady state responses comes after the transient response. And what are the different inputs? So the variation in input that are used practically to achieve dynamic behavior: step input. So the input is subjected to a finite and instantaneous change. So if you know square pulse, so one of the square pulse makes the step input. Ramp input, the input linearly changes with respect to the time. Parabolic input varies square of the time. So what is that example? It's an acceleration is one such of a parabolic input. Sinusoidal, you would have seen AC signals. So input changes according to sinusoidal function with constant amplitude. So these are different types of input input signal the system would be subjected to. Here the system is the instrument or transducer. So what are the different dynamic characteristics of measurement? Speed of response, fidelity, lag, dynamic error. Speed of response, it is defined as the rapidity with which an instrument responds to the changes in the measured quantity. It shows how active and fast is a system. So this gives the speed of measuring instruments. Fidelity, it is defined as the degree to which measurement system is capable of faithfully reproducing the changes in the input without further dynamic error. That is called fidelity. What is lag? So lag or delay is the time required by the system to respond to the changing input. So every system requires its own time to respond to change in the input. So this is called lag. So it can be classified into retardation or delay lag. So what is a retardation lag? As soon as there is a change in the measured quantity, only when there is a change in the measured quantity, the measurement system begins to respond. When there is a constant input, that it doesn't respond. Time delay. The response of the measurement system starts after the dead time or after the time of no response once the input is applied. So this period is called time delay. They cause dynamic errors. Okay. What is a dynamic error? Same difference between the true value and the quantity of the quantity that is to be measured, but here the quantity to be measured is changing with respect to the time. This results in a dynamic error, assuming there is no static error. Thank you.